Hello and welcome to the latest frog tip. In the frog tip videos we do some quick, important and cool modifications to our GBBRs. So today's hero is, like announced some time ago, again the M249 from VFC, the GBBR, and already it's converted to HPA like I showed in the previous videos. Be sure to check that one out, and in the video before that I converted it using as much steel parts and real gun parts as I could, so also be sure to watch that one. But today we will do the NPAS. So you see that I exchanged the barrel to 20-inch length, and additionally this is a tight bore barrel, 6.01 array tech, and the gun has quite big muzzle energy because of it. Of course it depends, because if you use the green gas maybe the effect would be different. But this video for the NPAS is applicable to all the guns regardless of if you use the HPA or you use the green gas. It's worth doing. So as I said, the barrel length and diameter boosted very much my muzzle energy in this machine gun, and as I measured it, this is 2.4-2.5 joules, which is far too much. What I'm allowed to do in the games I play is 1.9 joules for a machine gun. And you can ask, okay, so why you will not just dial down the pressure on the regulator? Yeah, I could do it, but I won't do it because first thing, this affects the cycling. So if I have to go down with the pressure from 120 to, honestly, like, I don't know how much would be the correct value, but maybe to like 100, the cycling will be very bad, yeah? Especially that I use the additional weight in the bolt carrier group to increase the kick, so I need some pressure. Additionally, driving the output energy by pressure makes a little sense, because then if you need to run multiple guns, then what? You're going to set different pressure for each gun. It makes no sense. This is not the only gun I'm using, so I want all of them to run on the same parameters and just not touch my regulator ever. So if not by the regulator, so how can I drive the power? Of course by gun parameters like barrel and so on, but it's ridiculous to try to pinpoint the energy that you'd like to have by buying proper barrel length or diameter. Yeah, it makes no sense. So the last option is to use the NPAS. And VFC guns in general came with NPAS for many years still now, and recently more and more of them don't have it. The NPAS is a negative pressure adjustment system. Is a very simple valve inside of your nozzle that allows you to set the muzzle energy based on the timing. Actually, I recorded a video how to make NPAS for VFC guns for rifles, and this was based on 5.56 rifles. I think 7.62 rifles do the exact same thing, but here in the M249 it requires just a bit more thought, and it's just a little more complex, yeah? So it's not difficult at all, but you need to have some consideration. So the topic of this video is making that valve so that you can set the energy to any value you need. How the NPAS operates, this was already explained in one of the videos I made, as I said. So if you are interested in the details, I will link it in the description, you can go there. And for this we will not need the entire gun, we just need the bolt carrier. We need to disassemble it, take the nozzle out, and then we will do the modification. So I'll start there. And for the modification I will use some parts. I will use this kind of headless M3x8 screw. This is a headless M2.5x5 screw, and this is a piece of plastic I printed out. The model for it will be in the description. Yeah, you can download it, print it yourself. And for those of you who don't have the 3D printer, you can just watch the video to understand what's going on, and you can improvise this part from any piece of plastic. Yeah, it's no problem. Apart from this, I need a hand drill, 2 millimeters diameter, and I'll be okay. So with all this information clear, let's do some field stripping. We need to take out the bolt carrier group. I think you know how to do it. You need to open this pin, break the stock down, and then you can pull it out to the rear. So here first the pin removal, In my case, the pin is extremely stiff after all the modifications I did. Yeah, so now I can lift up the feed tray cover, can break the stock. And what I have here is the spring guide. I just push it in up and it comes out. And now I need to remove the bolt carrier, so first put the gun on fire, not on safe, and just pull the charging handle to the rear. It's kind of like this. Okay. Okay, and we can put aside our opened gun. And this is what we will be working with. So first we need to remove those two screws on this side. And if they are Loctited, you maybe need to heat this up to loosen them. In my case, you see it goes quite easily. And when the screws are removed, you can take off first thing this plate. But there also, if you pull the nozzle, yeah, there is this plastic part inside that you can also remove. And now the tricky part. Here on the rear there is the screw that retains the return spring for the nozzle, and you need to remove it too. However, in my case, at least, when I rotate the screw, I rotate the whole nozzle. Yeah, I will show you. So you can imagine I catch the screw right now and I start to rotate it to remove it. And you see that the nozzle starts to rotate and still I cannot pull it out. So this is kind of issue, but there is a way to handle it. So inside of the bolt carrier there is this part, and that screw that we are trying to remove goes into this hole, right? On this side there is the spring attached, but if you look like this, it has like a cut, yeah, so it's like a flat-headed screw. If this part starts to rotate, like in my case, generally it should not, because it is not a full circle here. It has these walls that should retain it in orientation, but for some reason in my gun they don't. So the only way to do it is to put a flat screwdriver in here to hold it, and then you can imagine with second screwdriver remove the screw from the other side. I'm showing it like this because it will be very, very hard to show it here and record what's going on inside. But if you pull the nozzle out like this, and be careful here, you can pull it out until it leaves out of the bolt carrier, and the spring is long enough so you will not damage it. So if you just pull it so that you can put it aside, it's fine. And then you can put in this screwdriver, flat screwdriver inside, catch that part like I shown, and use second screwdriver from the rear to remove the screw, yeah? So this is exactly what I'm not able to show under camera. Okay, so now I caught it, and if I will take the second screwdriver and insert it into the screw, now I can fully remove it, yeah? So the screw comes out and everything comes out. And be careful when doing this not to scratch the insides of that gas cylinder with that flat screwdriver. Yeah? But you see here the part exactly like I shown in a second, and it has a seal and it has the spring attached. I just took the flat screwdriver and I put it in this slot, yeah, to hold it and prevent the rotation. Okay, now I don't need those parts of the bolt carrier group, so I will move them aside and I will focus only on the nozzle. The nozzle is pretty simple construction. There is one pin in this area that I need to push out. Okay, and I can take it out. The pin releases the spring, which we will not need. And also it releases the internal parts in the nozzle, yeah? So those internal parts, they are just inside, we need to push them out somehow. And for this I will use a long hex key. Important is that it's not sharp, so that you won't pinch anything. but this way I am able to like push this in, and I have this long guide, I have the valve, and also there is a spring that can fall off. Yeah, there is the spring. Here is a disassembled nozzle with all the parts. To quickly understand how it works, the valve basically is supported on this part, and I will explain it maybe in a little more detail because this is interesting. You can see if you put the valve like this, here, it fits perfectly to the shape of the support part. Right? You see that this radius fits, the angle here fits perfectly. You could think that it's the way how it should be, but definitely it's not. You will see later when I assemble it back that this is not the way you put it. The valve sits like this in this part, which is kind of strange, but honestly I think that VFC did it the regular way, so they oriented it such way that it was positioned this way, because if you have it like this, then if you put it in the nozzle, then the opening in the valve faces the outlet, or actually this is an inlet on the nozzle. So this is how they do it in all the guns. Actually this is how everybody does it in all the guns. But it doesn't work apparently, yeah, which is kind of strange. I experienced this because I thought this is the way how it should be. And the solution that I believe they found is to put the valve this way, yeah. So back of the valve will align with this inlet here on the nozzle, and this way the flow will be better and the gun will shoot normally, yeah. So this is pretty strange and pretty tricky, but this is something I noticed. So coming back to the parts, the support part, then the valve sits on this side and the spring is here. You can imagine that when the air goes in, it goes from the full side of the valve and then goes through, blows into the barrel, chamber and so on, and then when the pressure builds up, valve can close here and the pressure goes to the back, blowback happens, and when the shot is finished, when the gun reloads, the spring pushes the valve back into that position, yeah? So this is how it works. So this is the valve from the original M249, and this is an NPAS, original VFC NPAS. So you see that the major difference is that this one has a headless screw going through the middle. This rear wall is like thinner on this one, but it really doesn't change anything for the function. So what we need to do to make this valve an NPAS like this one is to add this kind of screw. So the screw is basically a support for the valve. So it sits on the screw, and when I, screw it more in, I push the valve more to the front, and it will take shorter time for it to close because already it's in forward position. If I unscrew, okay, then the valve is more to the rear. It will take longer for it to close, and of course the time that gas applies the energy to the BB will be longer, therefore higher muzzle energy. If you want to understand those details, watch this other video I linked in the description. So this is the first thing. We will be adding this kind of screw. Until this point, this is identical to the regular how to make NPAS for a VFC rifle. We will start with the valve first, and you will need to drill a hole here in the middle in the axis of the valve. So remember, the surface is at an angle and we want the hole to go in the axis. If you look closely on the valve, it's really easy to say where the middle is because there is a split line, because this is plastic molded part. And if I, for example, take a knife and I make a scratch joining those two lines here like this, this will be perfectly going through the axis of the valve, and then I just will need to drill in the middle. And I'm using M3 screw, and the hole has to be 2.5 millimeter diameter, yeah? This screw will cut the thread for itself in the part basically, yeah? So I will drill it, I will show how it looks after I finish. So I have my hole here, and remember that when you finish drilling you always need to clean this up, yeah? So like no plastic debris are flying around. So I did that, and now I can take my screw with appropriate hex key. This hex key will be also used to set the NPAS later. Put it from the front of the valve and basically screw it in. paying attention that it goes straight, because of course we are screwing, you know, steel screw into plastic and it can go, you know, at an angle sideways or something. So you really want it to go as straight as possible. Okay, and the screw went out on this side. Okay, so we can put this part aside now, this part. And another interesting thing that you can notice is that actually I'm doing it on two nozzles. One is dirty and one is not, because originally I recorded it assembling the valve the proper way on this support and it was not functional. So I reworked the solution the other way around, and I'm doing it on a spare nozzle to show how it should be, which is a little funny. To the point, we need to assemble this orange part. What this orange part will do, it will be a support for the valve, because you can imagine that right now when we have the valve with our screw here, it will slide off the plastic. If your screw has a sharp tip, it's also good to make it flat. Maybe I did not said it earlier, but the point is, if I put it like this, you see it barely hits on the plastic, it will be falling off. And if I show it from closer distance, you can see that the screw practically misses this plastic, right? So now we will put here this orange part as an additional support, and you will need to make sure that it fits nicely, like smooth surface here, that it really is on touch, yeah? But if we just add it, it will be too much to the front. So first thing what we need to do is we need to cut off the excess of that extension here, and you want to keep the same angle as you have on the front on this wall where you will cut it. The distance is negotiable. So you see my part is shorter. Yeah, what's the purpose of this part? And honestly, if you overdo it and the orange part is too much to the rear, nothing bad will happen, because finally it's the screw that will sit on this, the screw from the valve. So you can just unscrew it more and the valve will go forward to, let's say, make up for this distance that you cut off. Or you can just use a longer screw if the 8mm one is too short. Let's say, it's up to you. But from my experience, I want it to look more or less like this. And this distance I left here on the black part from the step to the front is 1.5mm. Now the time to attach this orange part properly to the black one. So the first step is apply some Loctite type glue, yeah? And you want to make sure that it goes straight. In my case, it's not fully straight, but I will fix it in a moment. First I need to wait until the glue settles. And now I will use the soldering iron to merge these two materials. So hot soldering iron, make sure to make it in a well ventilated space, yeah? And you see how I melt those two materials together. So you see how the black goes over the orange, orange goes over the black, all is good. And now I will need to take the file, and of course it's uneven after all this melting, so I need to shape it nicely on the sides to make it round and so that it, you know, fits to the general shape here. And from the front to just be perpendicular to the axis of that part. So here I have it, and it's still not perfect, but it doesn't have to. The important is that you can put it back into the nozzle, and here the support will anyway be on a screw. Why on a screw? Because it's a common issue in VFC type NPAS that when this goes back and forth, the screw hits on the plastic like, you know, thousands of times, and it cuts into it, and the more it cuts into it, the more power you have, yeah, because the valve reaches the back position, like more and more and more to the back. So for this reason you want to prevent it, and that's exactly why we are going to attach here that screw. And again, you want a flat surface fitting to a flat surface. So the screw, I set it with the flat, not the hex key side, let's say, so that it's flat, not opened here. And I try to position it by hand a little, and then I will again take the soldering iron and I will push this in as much as I can. And I will heat up the screw, pushing it in so that it goes all the way, yeah? Because I'm not able to screw it from that side, there is no interface for the key. So you see it's quite easy. I'm using PLA, and here it is. Of course the target is to have it as much in the axis of this part as possible. I have my flat tip on this side. Of course now it's cold, yeah, I waited until the plastic settles and the screw cools down. You can file it a bit if you want to, but I think this is unnecessary. And you can imagine that the valve right now would hit with screw against the screw, and this way it will not be wearing out over the time. And another thing to look for is this side. So remember that the valve has to slide in here, yeah? So we will be assembling it in a second. You must make sure that there is enough space on this side. So if not, then of course file off a little material from the orange here, so that the valve is loose. When we have all these parts prepared, we can start the reassembly. So take the spring and the valve, and remember that the valve goes with the back side towards the opening here. You see the opening? So it's oriented like this, and our part is also oriented like I explained. The opening part here with the flat orange goes this way, and all of this has to go back inside. And on the bottom here there is this kind of tab that you will have to position correctly in the nozzle, and if you push it all in, it goes nicely. And you can see how the valve is positioned, right? So the back side faces here, and there is that smaller diameter part in the middle, in my case, how the NPAS is set. The last part is to take this return spring with the O-ring, not to lose it, put it in, and you have to catch it with this pin that goes into this hole. And this nozzle is reassembled, yeah, the spring is there, the O-ring keeps falling away, but you can see here that there is the valve, and as I said, if you did everything correctly, it should be able to move back and forth quite freely. How to check it? You can try, like, you know, catch it with something, or actually I'm able to with even, like, don't use anything sharp, right? Because you can scratch it and then it can have issues. But this one is not sharp. I can pull it easily and it goes back, so it works. And now you have to imagine when you will be setting the power, you will use that hex key. You will put it inside of the screw that we just inserted, just the same way as for every single VFC and NPAS. And when you turn it clockwise, so this direction, then the screw will go deeper, and you see how this valve moves forward, which in practice will give us less power. And if you do this counterclockwise, you see the valve moves back, and this in turn will give us more power. So we have our modified nozzle. What is left is to relube, so you can spray silicone in there, and here apply some better grease that will stay, and put it back into the bolt carrier group. So we have now our parts. You see how much lube I applied. This is maybe excessive, but it will, in the worst case, it will be just blown out, so no issue. We need to put it back into the bolt carrier. Here again there will be the issue with this small screw on the rear, so you have to put it in, screw it, and if the nozzle starts to rotate like it did during the assembly, you need to use a flat screwdriver again and repeat this whole action I showed, yeah? So just in case you have the same issues, you already know what to do. So I tighten my part nicely, and now I can put in back this plastic part. So you remember it was in here, like this. Add this plate and those two screws, just to make sure it won't open during shooting. I will add a bit of a weak Loctite, yeah, so for both, just a little bit. And now all the way in. Okay, and our bolt carrier is reassembled. So the final thing is to put this back into the gun, of course relube this. Okay, so the bolt carrier goes back in. Because I did not remove the bottom trigger group, I will have to pull the trigger because it will block the bolt carrier, yeah, so I had to pull the trigger, but the return spring into the bolt carrier, yeah, the same way we push it in and down, it stays, and now we can close the gun. Alright. So what is left right now is to basically shoot and see where we are with the output. And unfortunately, to set it, every time you have to remove the bolt carrier group, so the return spring, bolt carrier, set the NPAS, put it back in, shoot again, until you get the value of the energy you want. Additionally, a thing I did not mention is that the shorter time it takes for the valve to close, the higher rate of fire of the gun. Yeah, it's also not a tremendous difference, but you will probably observe some rate of fire increase when you decrease the muzzle energy. So now I'm gonna shoot. I already showed how the gun had 2.4, 2.5 joules before applying the NPAS. So now I will set it to 1.9 joules on 0.36 and let's chrono it. So it was just a bit too strong. I dialed it down a little bit, let's see. So what is interesting also, you see that like the first shot was 1.952, I remember, and the next are lower, always with GBBRs, with hop up or the NPAS. Make like 3 shots before you start to evaluate, because after you change something it all has to, you know, feed back again. So I'm gonna take 5 more shots, let's see. Okay, trying to go on semi here. So basically you saw how the gun performs right now, and you saw that the power is actually extremely stable, because it was within 0.05 I believe joules, which is basically not achievable with the green gas, right? And at first I was a little too high, like 2 joules. I wanted 1.9 for my local limits, so I went down to 1.9 and have a precise setting there. So not to recommend the conversions for the HPA which I make, because for the M249 you actually don't have a real conversion. It's a very simple way how to convert it to HPA, but it kind of proves the point. So thank you for now. This was almost the last video about the M249. It's still not the last one. The last one is coming probably next week. And for now, let me know what you think. Hit the subscribes, likes, leave comments, reviews, whatever. I'm very happy to receive your support. That's what drives this channel to go on. And remember that the power of GBR shall be with you.